Okay, microphone's still on. All right, good. Okay, so this is circle unit day 6. All right, we're going to be rediscussing the center radius form, and then what we're going to be doing is we're going to be taking equations that are not in center radius form and putting them in center radius form. Okay, some real fun stuff coming up here. But here's a review of what yesterday's lesson was about. Okay, so the equation of a circle looks something like this. Okay, and this example is only for when the center is at the origin, okay, when it's at 0, 0. So when it's at 0, 0, all right, your center is right here, and then your radius is 4, so therefore your equation gets written like this, okay? Going over to the right side, all right, this h and k represent your center. Okay, so this we refer to as the center radius form, all right? And so in this case, all right, the center is at 2, -5. So the x's go with the x's, y's go with the y's. So your 2 goes in for your h. Your -5 goes in for your k. But if you notice, that is a -5. So this one would be x minus 2 squared plus y plus 5 squared. And then our radius is 3. So therefore our equation looks just like this. Okay, and so that's the only difference. The only difference is this one has center at the origin. This one does not. The R stands for the same thing, stands for your radius being squared. All right, and then you just got to remember this h and k, whatever this point is, just gets substituted into your formula here. Okay, so the general form of equation of a circle will have x squared and y squared terms, and these terms have the same coefficient, usually 1. So in order to view the center and radius, we will need to convert the general form into a standard form, center radius. This process, we will use your favorite, completing the square. Now some of you may be thinking, crap, I do not know how to complete the square. Okay, so I meant to take this one out. We'll come back to this problem here. Okay, well, let's go back down to, now this isn't, I just stole this from another unit. Okay, this is not unit 7, day 9, but completing the square to find roots. Okay, so this is how you do it. So here's our equation. Okay, and a lot of times when we use completing the square, it's because it's just not factorable. All right, so if we look at the factors of, well, I guess 15, 3, and 5, I guess that one will work. All right, but let's just do it for fun. All right, so if I were to just do this regularly, if I were to factor this, we look at the factors of -15, and we would say -5 and a +3. Okay, and so when this is both equal to 0, so it would be x minus 5, x plus 3. So when we multiply those two numbers together, we get -15, and we add them together, we get a -2. Set both of these equal to 0. And you get x is equal to 5, x is equal to -3. Okay, that is for when we factor it. Now I'm going to use completing the square, and I should get the same answers. Okay, the nice thing about completing the square and using the quadratic formula is that it's 100% effective for all quadratics. Okay, factoring has its limits. Okay, if for some reason this was a negative, let's say this was a -4 in here, okay, we wouldn't have any way of solving this problem because the factors of -15 are -5 and 3 and -1 and 15. There's really no other factors. So we would have to use completing the square if we had a problem like that. Okay, so let me switch this back. Okay, so we should get an answer of x equals 5, x equals -3. Let's see if we can do that. So when completing the square, your first step, okay, we got to remember too, this is big. Don't forget what your standard form looks like because we got to remember what these a, b, and c values are. Okay, so in this case, we want to put our constant on one side. So our constant is always that c value, okay, whatever is not associated with some sort of x. So if you look in the first problem, They took negative 15, they added it to the other side, and now we're left with x squared minus 2x equals 15. Then you take half the b and square it. Okay, so in this case, our b is negative 2. So you take negative 2 divided by 2, you get a negative 1, and then negative 1 squared is positive 1. And so this is what we're going to add to both sides. Okay, you got to remember, by doing that, by adding something to one side, you got to add it to the other. Okay, that's the additive property of equality. So if you look down here, that's what they did. So they took this value, this 1, and they added it to both sides. So now we're left with x squared minus 2x plus 1 is equal to 15 plus 1. Okay, now I'm going to show you why this is what we're doing this for. Okay, so if we were to factor this thing over here on the right, or on the left, okay? If we were to factor this bad boy, okay, we'd get x minus 1 and x minus 1 is equal to 16, okay? And the purpose behind completing the square is we want to have the same binomial being multiplied by itself twice, okay? That is the whole purpose of this. Okay, if we don't get something like this as a set of factors, then we had to have done something wrong. Okay, so if I were to factor this thing, you'd have x minus 1 equals 16. Well, x minus 1 times x minus 1 is really just x minus 1 squared. Okay? Now, we're just going to solve for x. Okay? So in order to solve for x, take the square root of both sides to get rid of that x minus 1 being squared. So you're left with x minus 1 is equal to plus or minus, and the square root of 16 is just 4. Add 1 to both sides, so x is equal to 1 plus or minus 4. Now you're thinking, well, that's not what we had up here. Well, realistically, when you're solving quadratics, we get two answers. So, we're getting x is equal to 1 plus 4, and we're getting x is equal to 1 minus 4. And then when you settle that up, you get the same values we had up top. Okay, so in order to complete the square, or the purpose behind it, is so that we are able to get our roots for problems that particularly can't be factored. Now this one could be, but in most cases when you're completing the square, it's because we can't factor. Okay. So, also too, a big thing is coefficients must be 1. Okay. I guess I could have just followed along down here. Right? But your coefficients must be 1. So in this case, we already started with that x squared. But when we're talking about coefficient, we're talking about that number that falls in front of that x squared. Okay, so let's practice some completing the square here. Okay. So, start with number 1 here. Okay, it looks like I'm going right into those. Okay. Oh boy. Oh, also, let me cross these out down here. I'm not going to ask you to do these. Okay, so going back up here. So let's practice some completing the square. All right, so this one here. All right, first things first, let's get our constant over to the other side. So we're going to add 56 to both sides. So 7b squared minus 14b is equal to a positive 56. Now, we want a leading coefficient of a 1, and as you can see, we have a 7 here. okay, which is no good. But conveniently, if I divide everything by 7 here, we're left with b squared minus 2b is equal to 8. Right, now we have our constants on one side. We have a leading coefficient of 1. And now we can finish completing the square. Okay, so we take our b value, which in this case is a negative 2. So negative 2 divided by 2 is equal to a negative 1. Negative 1 squared is equal to a 1. Okay. So what we're going to add to both sides is b squared minus 2b plus 1 is equal to 8 plus 1. And then we just did this one up above. Okay, if we factored this, we would get b minus 1 and b minus 1. And the whole point of that is so we're getting the same binomial being multiplied by itself twice. So let me shrink this up here because I am certainly running out of room. Okay, so this is going to be b minus 1 squared is equal to 9. Now another good hint, here's a little trick for you. Okay, this number right here, which is the first number you get when you divide your b value by 2, and our b value again is negative 2. Don't forget it's ax squared plus bx plus c is equal to 0. That's important. Okay, you're going to need to know that when you do quadratics as well. Okay, but if you notice at negative 1, where does that appear? Oh, look, right there. Okay, so if you ever get confused on what's going to go in this section right here, it's always this number right here. But that's a little trick. That's a little trick for you. You don't always have to recognize that though. But regardless, okay, when we go back down here, we get b minus 1 squared is equal to 9. We take the square root. We get b minus 1 is equal to plus or minus 3. Add 1 to both sides, so you get b is equal to 1 plus or minus 3. So we get two answers. B is equal to 1 plus 3. B is equal to 1 minus 3. So then B is equal to 4. And B is equal to a negative 2. Okay. Well, what this means is what we just found is that this is where these 2 points, positive 4 and negative 2, okay, those 2 points are where our graph, our quadratic, is crossing the x-axis. So these are our, what we want to call our roots. Okay? So let's try another one. All right? I'm going to add 48. Add 48. So you get m squared plus 2m is equal to a positive 42. Okay. Well, let's take a look at that b value. So that b value is 2, so divide that by 2. You get 1, and 1 squared is equal to 1. And so again, using that little trick here, all right, I'm not going to try to factor this. Well, I can. Let me actually write it out here so you guys can see it. So it's going to be m squared plus 2m plus 1 is equal to 42 plus 1. All right, and so now if we were to factor this and combine it, we would get m plus 1 squared, right, because that's what this factors out to be, m plus 1 times m plus 1. And as you can see, we see our plus 1 up there, okay, is equal to 43. Now, you're going to take the square root, and so you're going to get m plus 1 is equal to plus or minus the square root of 43. Now, this right here is an example of a problem that could not be factored. If we tried factoring this, it would not work. Only two methods would have to be quadratic formula or completing the square. Okay, so our last but not least, I'm going to subtract 1 to both sides. So you're going to get m is equal to, and you want to make sure you write it like this, negative 1 is equal, or negative 1 plus or minus the square root of 43. Right, you could either leave it like this, or if you like having it written as two answers, you can say m is equal to -1 plus square root of 43, and m is equal to -1 minus the square root of 43. Okay? Either way is correct, but you need to recognize that this is two answers here, not just one. Okay, so I'll let you guys try these ones for practice. Okay, and let's get down to the nitty-gritty where we're going in this. Okay, our goal here, okay, let me go back up to the top here. Our goal here is to use completing the square to put something like this into center radius form. Okay, so in order to do that, okay, you guys are probably worried, man, that there's two variables. We'll get there. Okay, we will get there. Now, the first thing you want to do is you want to put your x's with the x's and the y's with the y's. Okay, and then you want to take your constants and move them over to the other side, because we're still following the same rules of completing the square. We don't want any constants on the side that we're trying to complete the square with. All right, so I'm going to rearrange it. So I'm going to go x squared plus 2x plus y squared minus 4y is equal to a positive 11. Okay? So that's our first step. We got all of our constants on one side. Okay? And then what we're also looking for is our leading coefficients in both cases. Okay, the x's and the y's are at a 1, so we're good. Okay? We need to make sure that those things are at a 1. So this is a 1 coefficient. This has got a 1 leading coefficient. So we're good. All right. Now, let's take a look at this piece right here. I'm going to take a look at this piece right here. Okay, so if we were completing the square for a regular problem that just had x's, this is what we'd be verifying anyway. So our b value here is 2. So we're going to go 2 divided by 2, which is equal to 1. 1 squared is equal to 1. Okay, so in this part right here, we're going to go x squared plus 2x plus 1. Now let's take a look at this one right here. So our b value for the y's is -4. So we're going to go -4 divided by 2, which is a -2. And -2 squared is equal to 4. Okay, so plus y squared minus 4y plus 4. Now, we got to remember what we add to one side, we add to the other, so we got to make sure we add this 1 and this 4 to that other side. So in this case, it was a positive 11, so it's going to be 11 plus 1 plus 4. So our grand total here, squared plus 2x plus 1 plus y squared minus 4y plus 4 is equal to 16. All right, let's finish it up here. So we've already done a problem like this, okay? If we wanted to factor this thing right here, we would have x plus 1, x plus 1. If we wanted to factor this thing right here, x minus 2, x minus 2. Okay, again, using that little trick up there, there's our minus 2, there's our positive 1 here, okay? If you don't like that trick, that's okay. Okay, just know that when you factor this, we should get a couple of pairs. All right, so this one's going to become x plus 1 squared plus x minus 2 squared equals 16. And now this should look a whole lot more familiar. Okay, so we know what we can do with this one here. What's our center? Our center is going to be a -1 comma 2. And then our radius, we're going to take that 16 and square root it, and we get a radius of 4. Okay, so state the coordinates of the center and the radius. We just did. Did we convert it into center radius form? We sure did. And now we're done. All right, so let's go back down to those other problems. Okay, so for homework, I want you to try this one this one and that one. Oh. And I want you to try them all. Why not? Okay? I want you to try them all. So I'll do 5 and 6 here. And then I'll have you guys try the rest. Okay. So, looking at this one right here. Now what's nice of them is, hey, they got all the X's and all the Y's together. Okay, the problem is if you look in the front of the X and the Y, we see a 4. Okay, and so the best way to get rid of that 4 is to divide, the whole equation by 4. Okay, so let me zoom in there so we got some more space. So when we divide all this by 4, we're going to get x squared minus 8x. Right? Yeah, y squared, or not 8x, I'm sorry, 6x. Ooh, that would have been bad. So y squared, and then I don't know what 72 divided by 4 is. 16 maybe? 18. Okay. 18y is equal to, and that's got to be 19, right? 76 divided by 4. Cool. All right. So now, in order to solve this, okay, we're going to look at the completed square for this part here and completing the square for that part. So our b value here in this case is -6. So -6 divided by 2 is equal to a -3. -3 squared is equal to a 9. So we're going to go x squared minus 6x plus 9. Look at this one here. So 18 divided by 2 is equal to 9. 9 squared is equal to 81. So 18y so 81 is equal to 19. And then what you do to one side, you have to do to the other. So we added a 9 and we added an 81. So you want to do that in the same place, or on the other side. 19 plus 9 plus 81. I don't know what that is off the top of my head. 19 plus 9 plus 81. So you get 109 is equal to, whoops, all this stuff over here. Okay, so I'm going to simplify this. All right, so if I wanted to factor this bad boy, it would be x minus 3 and x minus 3. If I wanted to factor this one, it would be x plus 9, x plus 9. Okay, so I'm happy. I see that I have 2 pairs here and 2 pairs here. So I think we're good. Just a second, folks. Okay. So, this is going to be x minus 3 squared plus x plus 9 squared equals 109. And so our center, based off of this, because this is center radius form, remember, our center is going to be 3 comma negative 9. And then our radius, we're going to take the square root of that number. It's going to be the square root of 109. Okay? And that is our center radius. Okay, last one. So let me put the x's with the x's, which I already have. The y's with the y's, which I already have. And then the only thing I got to do is subtract 4 and get that on the other side. Okay, so the tricky part about this one is if you notice, there's nothing that's going with the x's. So that should tell you immediately that the point associated with the x values, your point for your x, is going to be 0. All right, because we don't see anything associated with our x value, but we do see some associated with our y. We got y squared minus 6y. So we got to figure out what our center is based off the information we got here. So I don't have to complete the square for the x, so I'm going to bring that down. I do have to do it for the y, though. So negative 6 divided by 2, which is a negative 3. Negative 3 squared is equal to 9. So we're going to go y squared minus 6y plus 9 is equal to negative 4 plus 9. Okay? And so we don't have to do anything with that x squared. We don't have to factor that. This one can be factored as, would be x minus 3. X minus 3. So therefore it's going to be x squared plus x minus 3 squared is equal to 5. And then here is our equation. So our point, our center, is going to be 0, 3. And our radius, take the square root of that 5, it's going to be the square root of 5. Okay, because don't forget, our equation is x equal to r squared. So whatever number we get out here is our radius squared. And so our radius squared is equal to 5. That means that we have to take the square root of that, so our radius is actually the square root of 5. Okay, so that's what it means by writing an equation without any radicals. Okay, up here we don't have any radicals, all right, because we took our radius and we ended up squaring it when we plugged it into the equation. Okay, so that is that lesson. So you got this one here, all these problems to try for homework. If you're already comfortable with completing the square, you don't have to do those ones at the top. Okay, they're just more or less kind of some extra practice for you. If you want to try these ones, you can. But if you're comfortable with completing the square and you're ready to just dive into some more heavier problems, then you can just jump right into 4 and 5. Okay, but if you haven't done it in a while, it would be good practice. And then skip those ones I've crossed out. Okay? All righty. Good luck, you guys.